Hello, matriculants. It is your chance now on our Triple M. Welcome and thank you for tuning in. This is our Triple M day, which is Mindset is Maths Monday, with me, Abram and Natasha. How are you, Natasha?
I'm very well, thanks, Abram. How are you?
You look so sad today. Did anything
Do I?
happen?
You know what? I think I'm sad because it is the last show of this term with the grade 12s, the last Monday show.
But anyway, I'm sure that they're capable now. They can stand on their own. I was saying earlier on that when it comes to the exam time, you don't need any teacher next to you. It's just you and your stuff, knowing what you've been taught and just, putting the effort, whatever you've been taught, it is just that time where you just need to show now.
Absolutely.
And what are we doing today?
All right, guys, so today we're looking at linear programming, which is really just revision from grade 11. So all of you who struggle with this section, it's going to be a nice revision session, in keeping with today's theme, really, which is revising through all of our grades. And I think if you struggle with linear programming, this is going to be a nice little revision session. And I can see that Abram wants to give you all the details of how you can get in touch, so I'm going to make my way over there.
Please do. You know your stuff. Right? Talking about people who know their stuff, it is people like you, Mindsetters. You should be knowing by now that when you are tuned in on our live shows, you should be having your cell phone next to you or your computer next to you, rather your iPad or your tablet just next to you. But either way, just be on our social networks because one, you can join us on Facebook. Our Facebook link is facebook.com/learnextra. That's where you can also guess and tell us when do you think we're going to hit 43,000 now, because we've hit 42,000 and you could win this awesome t-shirt. We've given so many t-shirts to other mindsetters, so you could also be that lucky mindsetter. But secondly, you can join us on Twitter at LearnExtra. Follow us and tweet us. But lastly, you can download your notes for free. Linear programming notes, I'll also share the link on our Facebook page. They are for free, guys. Download them and make sure that you study and learn with us, or else you can just download them on learnextra.co.za/live. Let's roll because it is our Triple M day. Natasha, take your time.
All right, take my time. Well, we're going to try and go a little bit faster, and I don't want to really take my time because we've got so much to do. So guys, today we're going to look at the revision of linear programming. As I said earlier, it is a grade 11 section. You all should have done it before. So if you find yourself getting lost in today's lesson, it may be that you need to go over linear programming thoroughly from last year. However, if you have a vague idea, today is going to be a nice way for you to recap all that you did last year and just to do a few questions and help you to get back in touch with linear programming. All right, and specifically we're going to look at constraints today. We're also going to do some questions that involve finding the feasible region and working with the objective function. So I just want to first remind you of a few things, like for example, what is a constraint? Okay, constraints, or we sometimes call them restrictions, these are placed on the variables being optimized. Okay, so constraints or restrictions are placed on the variables being optimized. The constraints also create the bounds for the solution. All right, and I'll show you this in detail when we do an example, but your constraints are going to create the bounds for your solution and help you to optimize whatever variables you've been given. Another very important word that you see in linear programming is the objective function, and that represents the function that we're going to use to optimize your solution. All right. And the feasible region, these are where your constraints basically mean that you cannot just take any old x and y value. All right, so when you're looking for the x and y that optimize your objective function, you can't just take any old x and y value, right? So we have to choose the x and y that will optimize the objective function, right? We call the set of all points that satisfy our constraints the feasible region. So your feasible region is made up of all the points that satisfy your constraints. Any point within the feasible region is called a feasible point. So any of those will be a possible solution. So you'll see later on, you get a lot of points within your feasible region that could be a possible solution, but they're not necessarily the optimal point to use. For example, if you want to maximize profits or minimize costs. Okay, but every point within the feasible region is called a feasible point. Once you have the feasible region, the solution of the problem will be the feasible point. Okay, and that feasible point is where the objective function is either going to get its maximum or minimum value. All right? Sometimes what you'll notice is that there will be more than one feasible point. Okay? And that's usually where the gradient of the objective function coincides with the gradient of one of your constraints. But when you get more than one feasible point, that means that the objective function is a maximum or a minimum, and in this case you have more than one solution. All right, when you get more than one feasible point, you get more than one solution. All right, guys, something you've got to be very comfortable with is converting from a word problem. As you'll notice, most of your linear programming is given in a word problem, and you've got to convert it to a mathematical description so that we can use it in linear programming. And what I've done in this little table, you notice, is I've just given you some of the common words that you see in linear programming questions, and then what you'll have to do is you'll have to convert those words into a mathematical description. So I'm not going to go through all of them. They are in your notes, as Abraham said he's going to post the notes for you on Facebook and that, so you can go through them at your own leisure. I just want to go through some of the important ones we'll be using and that we see over and over again, and the ones that you sometimes might get confused about. Right, if you see something like x is greater than or equal to a, greater than or equal to a, we represent that in mathematical form as x greater than equal to a. Okay, so that's quite straightforward. If it's less than a, very importantly, we don't have your equal sign, then it's just less than a. Those are straightforward, but the ones that often confuse people is this. X must be at least some value a. So x must be at least that value. So if it's got to be at least that value, it means it can be that value or more. So we represent that mathematically as x is greater than or equal to a. All right, so the least value it can have is a. Right? The other one that's sometimes confusing is x must be at most a. So if x is going to be at most a, it means the maximum that x can go to is a. Therefore, x has got to be less than or equal to a. All right, so these two are the ones that sometimes trick people and they sort of get tripped up and they're not sure what symbols to use. So make sure that of all these, you've got to know all of them, but of all of these words, make sure you understand the bottom two the best, because that's the one that tends to lend itself to confusion. All right. Okay. So what I've done for today is we're going to start off very easily. I just want to remind you guys a little bit about linear programming from last year. So I'm going to take it very slowly, show you how to get constraints in that given a very basic question. And later on in the lesson, we'll do exam type questions. So this is going to be a very simple reminder of how to approach linear programming. Okay, so this is question 1. You are given a test consisting of 2 sections. The first section is on algebra, right? So they tell you that you're dealing with 2 things, you're working with algebra, and then the other section is geometry. All right. Now, they start telling you straight away about some of the constraints. They say you are not allowed to answer more than 10 questions from any section. Okay, so they've already given you a bit of information that we can use later on. Then they say, but you have to answer at least 4 algebra questions. They say the time allowed is not more than 60 minutes. An algebra problem will take 2 minutes, and a geometry problem will take 3 minutes to solve. All right. Then they say if you answer X algebra questions and Y geometry questions, they then give you parts of the question to solve. All right, so as I said, I'm going to go through it very simply, a very easy problem this. The first question says, find the constraints which satisfy the above problem. And what I've done, if you look at the solution, is I've broken it up into steps. The first thing we need to do is identify the variables. Okay, so our variables here, obviously we're dealing with X and Y. But the X and Y represent something specifically. So we say, well, X is going to be algebra. Okay, so we've identified everything that refers to x is actually referring to algebra, and then y is geometry. So whenever we're talking about y in this problem, we're referring to geometry. The next step is to write down the constraints. To write down the constraints, we've got to go back to the question and pick out the information. All right. The first bit of information. They say, you are not allowed. So if they say not allowed, it means you cannot do this thing. Okay. You are not allowed to answer more than 10 questions from any section. That gives us a constraint, guys, because that means together with the algebra and the geometry, we can only answer 10 questions. And remember, x represents algebra questions, y represents geometry questions. So I know my first constraint is x plus y has got to be less than or equal to 10. We're allowed to go less than 10 questions, but we can't go more. You're not allowed to answer more than 10 questions. Okay, it's important to interpret, once again, the English into mathematics. So not allowed to answer more than 10, that means x plus y has got to be less than equal to 10. But you have to answer at least 4 algebra questions. Now remember, algebra is x. So at least, remember, this is what I was saying to you, it's one of those that sometimes gets a little bit confusing. If you've got to answer at least 4 questions, that means that you can't go below that number. So therefore, in this case, x has got to be greater than or equal to 4. Okay, you can't go below that number. So our second constraint is algebra has to be greater than or equal to 4. Okay, and we got that bit of information from the fact that they tell you that you must answer at least 4 algebra questions. Okay. They then say that the time, so now there's going to be a constraint on our time. The time allowed is not more than 60 minutes. Obviously, in every test, you know that there's a time constraint. You can't take 2 hours if you've only got an hour exam. An algebra problem takes 2 minutes, and a geometry problem takes 3 minutes. Okay, now guys, this is an important concept. If you're taking 2 minutes for one algebra problem, okay, so this is going to be the time, and I'm just saying this is the questions. Okay, so it's 2 minutes for one algebra problem. If you then answer 2 algebra problems, it's going to be 4 minutes, right? If you answer 3 algebra problems, it's going to be 6 minutes. Okay, so you notice what I'm doing. Every time I want to find out how long the questions are going to take me, I'm timesing the 2 by the number of questions. So therefore, if algebra takes 2 minutes, that means each of the algebra questions is going to take 2 times x, depending on how many algebra questions, and then the geometry is going to be 3 times x. 3 times y, sorry. So it's 2 times x, which is algebra, plus 3 times y, which is geometry. And remember, you've only got a maximum of 60 minutes. So that's got to be less than or equal to 60. Very important to make sure that your units are matching. We were given these 2s and 3s in terms of minutes, so therefore 60 minutes is correct to use. Now, something we call the implicit constraints. In other words, it always applies, even though we don't just go all outright and say it, it sort of makes sense. X and Y, we're always dealing with positive values, because obviously you can't answer a negative number of questions. So therefore, X and Y will have to be greater than equal to 0. All right, so those are constraints. Okay, so we've answered part A. Right, part B says the algebra questions carry 5 marks each. Geometry questions carry 10 marks each. So if T, which represents the total marks, write down an expression for T. So this is sort of our objective function in this question, right? So part 3 says, so part 1 we said identify the variables, part 2 we said write down the constraints, now part 3 write down the objective function. They told you that it takes, you get 5 marks for each algebra question, and you get 10 marks for each geometry question. So therefore, the total marks is going to be 5 times x, 5 marks for each algebra question, plus 10 times y, so it's 10 marks for each geometry question, and that will give you your total marks, because obviously if you answer just one algebra question, you're going to get 5, assuming you get it correct, and then if you answer just one geometry question, you're going to get 10, so then you'll get a total of 15 marks. Okay, so x and y, remember these are your variables, they can change. Okay, so the objective function that will maximize our marks is t is equal to 5x plus 10y. And what I want to show you, because that is the answer to part B, which is just writing down an expression for t. But what I'd like to show you, even though they don't ask it in this question, is that if the question required it, because at this point usually what would happen is they'd say write down the constraints, and then they would normally say sketch the graph and the feasible region. So obviously you will go with the question and you would follow. If they say sketch the graph in the feasible region, then you'd have to sketch the graph, as I will show you later on. You then will have to find the vertices of the feasible region, and that's important because it usually helps you with the next part, which is to use the objective function to either maximize or minimize your solution. Okay, but all of that is going to really make sense now when we do a harder exam type questions that you guys can expect in your final exam. All right, and I think it's about time that we take a break.
Yes, indeed, Natasha. Now, mindsetters, as we're taking this break, it is not just any ordinary break where you just need to go outside, get something. You still need to be where you are right now. Watch this trailer, and then after this trailer, I'll be giving you details about our After Earth competition, because this is a movie that's coming out on the 7th of June, and it is starring by Will Smith and his son, Jaden Smith. If you'd like to win this movie tickets, make sure that you watch this. Welcome back, matriculants. It's still our Triple M Day, which is Mindsetters Maths Monday, and we're having so much fun doing linear programming. I hope you're learning as much as I am. But now, telling you more about the competition, seeing the trailer that you've just seen now, you know what? This movie is a must-see. Now, the winner for last week's show on Thursday is Charlotte Mukuseni. Congratulations to you. Double tickets are on your way for you and your friend to come watch this movie at any cinema. Remember, it is coming out on the 7th of June this year. Few weeks to come, we'll be there also watching it. So make sure that you don't miss out. Now, if you don't want to miss out, make sure that you enter. Actually, you know what? It's this Friday. So you don't have any other chance now or any other excuses rather than to use the opportunities that we are giving you. Now, to win these double tickets, all you need to do is to enter for today's competition by listening to me as I'm giving you this keyword, which is expansion. Expansion, expansion. Matriculants, your keyword for this competition for today's show is expansion. Make sure that you go on learnextra.co.za/After Earth and enter for the competition. Otherwise, more details will be on our Facebook page. Natasha, take your time. Hopefully, you also come and watch this movie.
Oh, absolutely. And guys, I know it's all this exciting stuff going on, and you're entering competitions and all of that. Hopefully, you find some time to fit in some maths today. So let's get straight to it. Now we're going to start looking at some exam type questions, typical type of questions that you can expect. All right, so this is question 2. And there's a lot of words, okay? So you've got to sift through the words and get your information, as you'll see. All right, so they say that a team of tennis players consisting of men and women must be selected as follows. Now, generally, when they give it to you in this nice way, these little points are probably going to give you your constraints, so you've got to read through them carefully, right? They say the maximum, remember maximum, what does the maximum mean? It means the most, right? So the most number of team members is 25. That's the most number of members you can have in any team, okay? There should be at least, remember when you see the word at least, it means greater than or equal to some number, right? So there should be at least 14 men, And then they go on to talk about the accommodation. They say the team will be accommodated in chalets for 2 nights. Okay. Men will be accommodated at the rate of 300 Rand per person per night, and women at a rate of 500 Rand per person per night. I don't know why it costs more for women, but anyway. And they have 18,000 Rand to spend on accommodation. So in total, over those 2 nights, they've only got 18,000 Rand to spend. They then tell you very nicely, they've identified the variables for you. They say let X represent the number of men and Y is the number of women. So X is the number of men, Y is the number of women. And, you know, as expected in an exam question, they'll then ask you to write down the constraints as a system of inequalities in terms of X and Y. Now, in order for us to write these as inequalities, we first got to determine what our constraints are telling us from the given information, okay? And sometimes it's useful, well, it's actually always useful, to write down your constraints in terms of just an equation and then fill in your inequality sign if you can't really see what's happening. Okay, let me show you what I mean. Okay, so the first one, they say the maximum number of team members is 25. Now remember, your team is made up of men and women. So therefore, okay, this is now the solution. So the one constraint is going to be the number of men plus the number of women can only go up to 25. Okay, also remember we've got implicit constraints, X and Y are always greater than equal to 0. Okay, so the first one, X plus Y is less than equal to 25 from the first bit of information they've given you. The next tells you there should be at least 14 men. So we want 14 men or more. So therefore, the number of men has got to be greater than or equal to 14. Right, now this one you've got to be careful with, the last constraint. They say the team will be accommodated in chalets for 2 nights. Okay, but then they say they give you the rate per person per night. And guys, you've got to be careful here because they're giving you the rate as 300 Rand for men per night, but they're going to be there for 2 nights. So obviously over 2 nights it's going to cost 600 Rand, right, for one person, for the men. And then similarly for the women, it's 500 Rand per person per night, but they're going to stay there for 2 nights. So it'll be 1,000 Rand per woman. Okay, so you can't leave out this 2 nights. Okay, so how do we include it? We'll say, well, we know that it costs 300 Rand per night to accommodate a man, plus 500 Rand per night to accommodate a woman. However, they're staying there for 2 nights, so we need to times that whole thing by 2. If you don't want to do that, you could just say 600x plus 1,000y straight away. And we know that altogether they've got 18,000 Rand to spend. So that's all got to be less than equal to 18,000 because obviously they can't go over this number. That's all that they've got to spend. Okay, all right. So those are our 3 constraints. X plus y is less than equal to 25. X is greater than equal to 14. And I'm just going to simplify number 3. So let's divide through by 2. So I'll get 300x plus 500y is less than equal to 9,000. I've just divided the 2 out. Okay, and I'm going to simplify a little bit further because we don't like these big 300s and 500s. We can divide through by 100. Okay, so I'm dividing here by 100. And I get 3x plus 5y is less than or equal to 90. Okay. So just make sure that when you answer this, you get your constraints right. Because if you're going to get this part A a little bit confused and mix up your constraints, you're going to see later on when we try to find the feasible region, it's not going to make sense. So be very, very careful to get the first part of this correct. Okay, let's look at part B. They say use the graph paper, and usually in an exam they'll give you the graph paper to show these inequalities and clearly indicate the feasible region. Okay, now remember your feasible region is where all of your constraints intersect, or where they all match and give you a nice area with feasible points. Okay, so I'm going to do, we've got x plus y is less than equal to 25. I'm going to show you the first one, how we draw it, because remember we're just dealing with straight lines, but we're not sketching an equation. We're sketching an inequality. So if I've got x plus y is less than or equal to 25, it's got to be all points where you add x and y and it's less than or equal to that value. All right? But to sketch it, what you can do is you can think of it as I'm working with an equation. Say you were working with x plus y is equal to 25. How would you sketch this? You would say find the x-intercept by saying let y equal 0. And then you would find the y-intercept by letting x equal to 0. So you'd sketch the line itself in the similar way that you would any ordinary straight line. However, your interpretation, because of this inequality, is going to be different. It's going to be all points that are below that line. Okay, so if I use the x and y intercept method, I'm going to get the points to plot. My x-intercept is going to be 25 and 0. And then your y-intercept is going to be 0 and 25. Okay, you all should be quite skilled at finding x and y intercepts by now. Okay, so let's draw that first point on our graph. Okay, you'll see what we've done, guys. Very important again, label your axes correctly. You'll see that on the x-axis, we've got number of men, because remember x represents the number of men. On the y-axis, you've got number of women. Okay, y represents the number of women. You'll see that we're using a scale where each little block represents 5 men or 5 women. Okay, now remember, because we're dealing with people, very important when we later look for our feasible solution, when you're dealing with people, you can't have 9.5 people. It's got to be whole numbers. Hey, you've got to keep that in mind. In fact, what I should have done in this one specifically, it's actually on this one, is when I set up my constraint, it wasn't just x and y that's greater than 0, they also had to be whole numbers. So x and y would be an element of whole numbers. Okay, because we can't have a fractional number of people, just to be completely correct. Okay, let's sketch the first line. Okay, there we go. So remember, we're using a scale of 1:5. And the first one was x plus y is less than equal to 25. We saw that our y-intercept was 25, so we put a dot at 25. Okay, that's going to help us sketch our line. And then the y-intercept was 25, so we have another dot there. We're going to join those 2 points, right? Okay, so I've got my straight line. It's going to go from there to there. Okay, so that's the first line, that's line 1. Let's go back to our information and write down, or use the other information to draw our lines. So that was x plus y is less than equal to 25. At that point, I just want to remind you, when we say an x plus y is less than equal to 25, because I'm swapping between slides, my pen keeps disappearing, but we're talking about all points that are less than that line, so less than that straight line. Okay, so that's sort of what I was saying to you before. It forms a boundary for your feasible region. Okay, so we're only interested in values that are less than or equal to 25. All right, let's go back to the other line. Our second line was x is greater than equal to 14. So how do you sketch x is greater than equal to 14? So we know that that's referring to the number of men, which is our x value. And they say x has got to be less than or equal to 14. Now that's just going to be a straight line cutting through the x-axis. Now remember, each of these represent 15, so 14 is going to be very close, so each block represents 5. 14 is going to be quite close to 15, and we simply draw a straight line straight through that point. X is less than equal to, and I'm just going to draw that again so that we get it a bit straighter. There we go. All right. And it's all points less than equal to 14, so it means it's all points to the left of that line. Okay. All right, and then the last bit of information said 3x plus 5y is less than equal to 90. Now guys, with this one we've got to do a little bit of work to work out our coordinates, our x and y intercepts. So we're working with this one, number 3. 3x plus y is less than equal, 3x plus 5y is less than equal to 90. So remember I said to you, you can think of it as a straight line, as you would sketch a straight line. We find the x-intercept by letting y equal to 0. And I'm going to do this quickly because I assume that you all know how to work out your x and y intercepts by this stage. So x-intercept, that means y is 0, okay, which means this term is going to disappear, and we'll get x-intercept is 30. And then for the y-intercept, we know that the x value is 0, so that means that first term there is going to disappear. 5y is less than equal to 90, so 90 divided by 5, and my brain's not working at this time of the day, so use our calculator. 19 divided by 5 is 18. So therefore we get 0 and 18 is the y-intercept. So as you would sketch a straight line, you work out your x and y intercepts. On our graph we're going to plot 30 is x, 30 on the x-axis, and then 18 on the y-axis. So that's just below 20. Remember, this represents 15, so 18 is somewhere there. All right, and then we're simply going to join those 2 points. Okay, and here, again, it was less than that line, so it's all points that lie below that line. And what you'll notice is all your arrows then intersect where? They're all going to intersect, and I'm going to take these out now because they look quite untidy, but they all intersect in this little region here, which we're going to call the feasible region, but I'm just going to tidy that up just a little bit. Well, actually quite a lot. All right, so remember we're looking at values to the left of that line, beneath this one, and beneath that one. Okay, so therefore this is our feasible region in this area here. And I'm just going to color that in a completely different color so you can see where all of our feasible points lay, and hopefully you can see this on your screens. So it's just going to be this little area I'm going to highlight in yellow. Okay, let me try that in a different color. I don't think it really shows up nicely. Let's try the green. Okay, there, that's a little bit better. Okay, so that's your feasible region in that area. Now remember, these are all points that could possibly make this whole solution, they could give you a solution to the equation, but they're not necessarily going to give you the optimal solution. Now, in order to get the optimal solution, we need the objective function, which I think is the next part of the question. Okay, they say if the individual women obtain 10 points for a win, remember women is represented by y, don't confuse your variables, and men get 6 points. Give an expression for the maximum number of points it is possible to obtain, and they say 1 event per person. All right. So we know that women get 10 points for every every game that they play or every win, and men get 6 points. So it's going to be 10y plus 6x is going to give us our total points. So I'm just going to call the points P, and we know that P is given by 10y plus 6x. That's that part of the question done, and that is our function that we are going to use to answer part D, which says determine the number of men and women in the team that should be selected in order to maximize the number of points. Now this is important. We needed that objective function from part C in order to help us with part D, which is maximizing the number of points. First thing you need to do is you need to rewrite your equation. Okay, remember you've got points is equal to 10y plus 6x, but we now need to rewrite that so that we can sketch this, all right? So what we need to do is we take the 10y over to the left-hand side, bring the p over to the right-hand side, and then we're going to divide through by minus 10. So we get y is equal to negative 6 over 10x plus p over 10. We're really interested in the gradient because the gradient is going to give us the search line, all right? We can divide 6 by 2 and we're going to get 3, and then 10 by 2 gives me 5. So this is what's really important. The gradient of the search line is minus 3 over 5. So if we want to maximize the number of points, we need the line, the search line, to have that gradient 3 over 5. Okay. And remember, the question said, determine the number of men and women that should be selected in order to obtain the maximum number of points. So we go back to our grid now. We know that our objective function has a gradient. Okay, and I'm just going to rewrite it for you here. Our objective function is y is equal to, it's minus 3 over 5x plus p over 10. This is what we're interested in. That gradient of the search line is going to be the one that we use to maximize that. Now, in order to draw your search line, you've got y is equal to minus 3 over 5x plus p over 10. You need to maintain a line that's going to have a gradient of 3 over 5. Okay, so now that you know where the feasible region is, there's that little area there, I'm just going to take that off. Okay, remember the gradient we're looking at here is minus 3 over 5. So what you're going to do is you're going to go from your y-axis to your x-axis, and you're going to need a gradient of 3 over 5. All right, guys, we need to quickly get through this, but we've got so much to cover. And I hate to leave it at this point because we're really right at the end, but we have to take a quick break, and when we come back, we'll finish it off.
Right, as we take that break, a big shout out to the mindsetters that are watching right now, such as Shikash Inderjit, who is a brother to Priyashka Inderjit, if I remember very well. A big shout out to you and to your dad and your mom and your friends who are watching the show. Thank you very much, mindsetters. A quote just before we go to the break is that work hard and become a leader, but be lazy and just become a slave. But mindsetters, we want you to be leaders. See you after this. Welcome back, matriculants. Now it is that time where we still learn more using this time that we have. But Natasha, there's a concern from the mindsetters that they think we've made a mistake there, such as Levi Moret saying on the graph there, it was supposed to be greater or equal to 14.
Yes, absolutely, guys. Well spotted. I'm glad that you're all awake, and I'm actually glad we took that break because I had time to have a look and see that as well. It was x is greater than equal to 14, as you said, rightly so. So that's going to change your feasible region. Your feasible region is going to be, let's just get a nice color here. It's going to be this little portion within these boundary constraints. Okay, so it was x is greater than equal to 14, which means it's everything to the right, not to the left. Okay, so well spotted, and I'm so glad that you are all wide awake. Okay, so that's going to be our feasible region. I'm quickly going to go over as well how we found our search line, the gradients. Okay, let's just go back there. And I just want to show you the question told us that a woman gets 10 points for a win and men get 6 points. So I then formed the objective function by saying the maximum number of points. Remember, each man gets, let's just make sure that I have done that correctly. Women get 10 points, so that's y, and then men are 6 points, which is x. So therefore, it's 10 points for every win that a woman makes. So therefore, it's 10 times y, plus 6 points for every win that a man gets. So therefore, our points equation is p is equal to 10y plus 6x. When we need to then maximize the number of points, we have to rewrite that equation, which is what I've done in the next line. So I've rewritten it as minus 10y is equal to 6x minus p. So I've literally just taken that and taken the y over to the left, moved the p across. I've divided through by the coefficient of y, which is negative 10, and then we then get it in this form, which is minus 6 over 10x plus p over 10. Simplify that to minus 3 over 5, and that is what we call a search line. Okay, your search line or your objective function helps you to find the maximum or minimum values that you're looking for. We're then going to use that gradient of minus 3 over 5 to help us maximize the number of points, okay, and that's where I'm at now. So we've got our gradient is 3 over 5. So therefore, remember, our feasible region is within that little white area. Our gradient is 3 over 5. So to get a gradient of 3 over 5, guys, there's different ways you can do this depending on your scale. You could go rise over run. Okay, some of you will remember change in y over change in x. So you could go 3 units down, 5 units across. Okay, and then you could plot your points like that. Or what you can do is you can find equivalent points and then plot those points. That will give you a gradient of 3 over 5. Whatever method you use is absolutely fine as long as you maintain the gradient of minus 3 over 5, which is going to give you a line that looks as so. And I'm just going to get our search line in. All right, and I'm going to make it quite long, and you'll see why now. Okay, so that's my search line. And this search line, we're going to actually move it up and down to get, whoopsie. All right, and I seem to have made a bit of a mess there with my page. There we go, it's back up, thankfully. All right. With the search line, we're actually going to move it up and down, maintaining the same gradient. Now, how do you maintain the gradient of 3 over 5 or negative 3 over 5? You have to move that line parallel. Okay, so I'm going to show you how to do that now. All right, so this little pink line, remember, this is your search line. Okay, and I just need to delete that extra line that I made there. There we go. That's the one I'm interested in. The pink one, which is our search line, which has the gradient minus 3 over 5. And we're going to move that parallel so that we get the same gradient. Parallel means you're going to keep this at the same distance. Remember, parallel lines have the same distance between each other. So we're going to keep moving that line in a parallel fashion. Okay, so you can see that I'm moving it. Okay, with the same gradient, and if we're trying to maximize points, we're looking at the last point where this pink line, our search line, is going to touch the feasible region. Okay, to maximize, you want the last point of your feasible region that it can possibly touch. If you're trying to minimize, you're obviously looking for the first point. Okay, and as you can see, I keep moving it parallel, and there we go. We can sort of see it there, the last point on my feasible region that's going to maximize my solution is at that point there, which is the edge of the feasible region. Remember, you've got points A, B, C, and D at the edges of the feasible region, and this is the one at point A that's going to maximize the number of points. You will be given graph paper. You will be able to read it off accurately, but we know that that means it's 14 for men. So it's 14 men on the x-axis. And then if we go across here on the y, it's just less than 10, so it's going to be 9 women. Okay, so 9 women getting wins and 14 men getting wins will give you the maximum number of points. Okay, all right. So with the search line, I mean, you're going to have a ruler in school and you'll be able to move your ruler parallel and you'll have a nice accurate graph paper and all of that, so you'll be able to read it off. Okay, all right. I want to quickly go over the last question, which is quite an important one. And in this one, what we're going to tackle is something where they actually sketch the graphs for you. So they give you all of your constraints on a graph, they give you your feasible region, everything's given to you. And you've got to then interpret what they've said to you. Okay, so let's go through that quite quickly. All right. So this is from the November 2009 paper, and it's paper 1, question 13. They tell you that a steel manufacturer makes 2 kinds of products. You've got product A and product B, and they have parts that must be cut, assembled, and finished. The manufacturer is aware that it can sell as many products as it can produce. They then tell you, let X be the number of units of product A, and let Y be the number of units of product B. Okay? They say that the constraints that govern the manufacture of the products are represented in the feasible region. Okay, so here they actually give you all the constraints. All the answers are in this graph. You simply have to decipher them. Okay, so you need to be able to interpret the drawing that they give you and write it in terms of inequalities that make sense for the information that they give you. All right, so the first question says, write down the constraints in terms of X and Y that represent the above information. All right. So we want to write down the constraints in terms of X and Y that represent the above equations. Now let's have a look, guys. We've got a few lines here. We've got, I'm just going to call that 1. So 1 is going to be in blue. Yes, let's use lots and lots of colors. 2 is going to be that one in purple. And then we've got this one is 3. Okay, we've got 3 different lines, and we've got to find out the inequalities that represent those lines. Now, from the graph, you can see that all of these are lying less than or equal to their boundaries or their restrictions. So, therefore, all of our inequalities are going to be in terms of less than or equal to. Okay, because that's what our feasible region is showing us. All right, I'm just going to undo that so that we get rid of all of those little yellow arrows. Okay, so let's start with equation 1 in blue. If you look at the end points of this line, we see that the number of units of B, we've got a y-intercept of 8, and the number of units of A, we've got an x-intercept of 8. So therefore, it's just your normal straight line. You've got 2 points. You've got x-intercept of 8 naught and y-intercept of 0.8. So we're going to use those 2 points as we would in any equation. I'm going to do this in detail because the others I'm going to go through quite quickly. We first need to work out the gradient. We say the gradient we get by y2 minus y1 over x2 minus x1. So it's going to be just using the coordinates you've got, 8 minus 0 over 0 minus 8, and that's going to give me a gradient of minus 1 for line 1. Okay, remember it's just a straight line, so it's going to be y is equal to mx plus c. Obviously we need to convert that into an inequality, but your y-intercept is already given. We know that it's 8. So therefore, if it was just a straight line, it would be y is equal to negative x plus 8. Right? But it's not just a straight line, it's an inequality. So therefore, remember, it's all values as shown in your graph that are less than or equal to line 1. So therefore, line 1 is going to be y is less than equal to minus x plus 8. Okay, so that's line 1. In a similar way, guys, and as I said, I'm going to go through it quite quickly now. Line 2, which is the one in purple, you see that your y-intercept is 6 and your x-intercept is 18. So therefore, your gradient is going to be negative a third x, and your y-intercept is 6, so it's going to be negative a third x plus 6. So you get y is less than equal to negative a third x plus 6 as the equation or the inequality for line 2. And then finally for line 3, which has a y-intercept of 14 and an x-intercept of 17, our gradient is going to be minus 2. All right, so it's minus 2x plus your y-intercept is 14. So we get y is less than equal to minus 2x plus 14. And I went through those inequalities very, very quickly. I hope that you all understand from the first one that I did in detail. Okay, but those are the inequalities that you get just from looking at your graph. Now guys, what we've done is I've actually prepared a solution for you for this question, so I'm going to fly through it. If you don't understand, the notes are online, so you'll be able to go through it there as well. All right, after that they give you the profit product. A is 30 Rand and B is 40 Rand, and they want you to write down the daily profit in terms of X and Y. All right, so let's have a look. So this was part A, which was our finding the constraints, okay? Now for part B, they say product A yields a profit of 30 Rand per item and product B is 40 Rand per item. Therefore, write down an equation. Now your profit equation is going to be 30x, because it's 30 Rand for product A and 40 Rand for product B. So it's 30x plus 40y will give you your profit equation. They then say determine the number of units of product A and product B that the manufacturer needs to produce in order to maximize that. So what you need to do is you need to take this equation that you've worked out before, rewrite it in terms of y is equal to. So you rewrite it, you're going to get a gradient of minus 3 over 4x plus p over 40. Remember, this is the gradient of your search line. So on your drawing, right, you then have your search line, which you put in here, and you can see it's this line with the gradient minus 3 over 4, which is this one here, that you're going to move. Okay, this is the line you're going to move parallel and try and see how you maximize or minimize that line. Okay, so that's your search line that you're going to move. Okay, and as I say, I'm going through it very, very quickly because we need to quickly finish it up. Okay, so that's your search line that you will use to maximize. If you do it correctly, right, you will move the search line along until the last point of the feasible region that it hits. That will give you the maximum. So we would get the maximum at 3 and 5, the last part. They say that they want the maximum to be at the point 6 and 2. So determine the values of m which will satisfy that point. All right, so 6 and 2 is actually this point here on the graph, and it's actually bound by these two lines with the gradients of minus 1 and minus 2. So for you to land up at that point, your gradient needs to fall between minus 2 and minus 1 so that you get to that point 6 and 2. Guys, I flew through that, and I do know it was probably very difficult to take in all that information, but we are running out of time, and you do have the notes online. So please go over it and make sure that you understand. It is our last live one for Monday, so good luck with the exams. Cheers.
Thank you so much, Natasha, and hope to see you some other time again. Right, to you Mindsetters who took your time to learn with us, we just want to say we appreciate. Thank you very much, and study very hard, guys, and very smart, because we're here to help you. Also, make sure that you also access our Facebook page at any time, facebook.com/learnextra. We really appreciate it, and we just want to leave you with these wise words that never ever stop believing in yourself, because when you stop believing in yourself, no one will ever believe in you. We love you, and peace.